Hello, my name is Nisi. I live here in Ontario, Canada. I'm a data engineer with loads of experience building and optimizing data pipelines. I'm going to be teaching you loads of these skills. So if you're a beginner in data engineering and you'd like to get hands-on, please hit that subscribe button. If you'd like to learn concepts ranging from data warehousing to pipeline orchestration to working with loads of databases and data formats, please also hit that subscribe button. You could also expect content around building schemas, deploying pipelines, deploying machine learning models, all of these things. Today I'm going to be teaching you some SQL. I think it's really important to discuss how to solve SQL problems, because SQL is something I think that's the common denominator amongst all data related professions. I think in interviews you'd commonly see SQL being asked, and you'd commonly have to solve SQL problems. So I think it's really good to get hands-on with some basic SQL concepts. It'll be good to see those put into practice in a couple of SQL problems. So let's dive right into Leetcode and get started. Great, we're ready to get started. If you go to Google, you should be able to search for Leetcode's 50 SQL interview questions. I think it's pretty popular. Should be able to get that. And I would also leave a link in the description so you can easily access this. So looking at all the questions, you can see that there's questions ranging from easy to hard. There's only one hard problem here, but I think it's a fair mix of easy and medium questions, which is really good. So I'm only going to be working on 2 today, just because it's going to take some time to explain the concepts while I work through the solution. So let's head right in. So the first one is restaurant growth. I think this problem is really interesting because it talks about a moving average, and this is something you can accomplish with window functions. Now if you think about window functions, windows, right? So it's sections of your SQL tables. So it's particular partitions, if you like, of your SQL table, and a moving average would only mean that you have windows moving. So a window moving from one row to another. And obviously a window can be one row, it can be several rows, if that makes sense. So a moving average will just be the average of a window, and that average moves along starting with one row and moves sequentially across other rows, if that makes any sense. And the entire concept of window functions is that you're trying to perform some aggregation without losing the underlying granularity of the data. So if I wanted to do, say, a sum, if I wanted to do the sum of an entire table and have that sum in each row in the table, so that's not sacrificing the granularity of the table, but I want to have the sum, which is an aggregation of the entire table, for which you'd usually have to do a group by clause. So you could do that by including an extra column, which would be a window, which will be accomplished using a window function. So in this case, let's carefully read the problem statement. So you're a restaurant owner, and you want to analyze possible expansion. So if you go to the table, you see that there's the primary key here, which is the customer ID column, and there's name, visited on, amount, compute the moving average of how much the customer paid in a 7-day window. So 7-day window will essentially be 6 days prior, including the current day, which would make for 7 rows, and round this off to 2 decimal places, have the visited on, so we'll have an order by clause at the end to have this in ascending order, which it is by default. And let's see an example. So let's think about this. What if we had visited on, a date repeated in visited on? We would want to first aggregate the visited on, and then we'll have to calculate the moving average. So in order to check that, we could find out if there was any repeated visited on dates, if that makes sense. So I'm going to quickly do that. So I'll just select visited on, and I'll just do the count because I want to see if it's repeated. I'll just copy the table name here. I've copied that twice. Then we group by, of course we group by this, and I want to do having so I just want to run this and see if there's more than one count. If they're visited on dates that appear more than once, is that the case? Oh, there's one of such dates. That would be the 10th. Okay, perfect. So that means we have to first group by and get the total for each visited on date, and then we can proceed to computing the moving average. So let's do that. I would like to put this in CTs just to keep things neater. So I'll call this daily totals. And here what I want to do, so let's just go back and copy what we had here just to make things easier. So, daily totals. So only difference would be this would be sum of amount as I'll just call this something like this, and this shouldn't be here as well. Great. So then we have the second table. We should call that final or whatever. And in this case, we want to compute the moving average. So I'll start by selecting. Now, what would be the moving average? Let's see what the output should look like. We want to have visited on amount and average amount, right? So that tells us we have to fetch visited amount. And there's this clause you can pass into a window function that's called rows between. So in this case, it says 6 days prior plus the current day. So 6 preceding and current row. This is what we have. So essentially what this does for us is, including the current row, it looks 6 rows prior. So I'll just keep this here. And now what we want to do, obviously it's asked for the total, right? So we have to do a sum. We do a sum and then we do over. And this has to be ordered. In order for this to work, you have to order by the visited on. So we're going to order by visited on. And then we could copy this. Order by visited on. Oh, apparently that didn't get copied. So just paste it here. Great. And would like to call this amount. Awesome. Then it'll be something similar. We could do the next one. Here should be average. Amount should be in here as well. Okay, so this should give us the moving average and the moving total like we're asked to compute here. Right, so let's see if that works. And this is going to be from daily totals because we computed the daily totals for the visited on, and then we have to fetch that from this table, the table that's shown in the city here. And then we can finally select all from. Final. Let's just look at this one more time. Hopefully this works. Okay. I suspect this wouldn't quite solve the problem, but let's see if this runs. Unknown column field list. Okay, I know where that is coming from. So we should have total amount here instead. So just change that. My apologies. So let's work with this. Duplicate column should be average amount. Okay, now this says wrong answer. Now if we compare the output against the expected, you see that we have the correct totals, average and totals, but you see that we have 1 to 6, which we shouldn't be having, because moving average, it says a 7 window, right? A 7 window, which means the first should start on the 7th, and then that's computed from 1 to 7, and for 8 it should compute from 2 to 8. That's what moving average is. So window from 2 to 8 would be a 7 window, and then the next one would be from 3 to 9. So each one should be a window of 7, if that makes sense. So what we're going to do is introduce the row number. Now if you know the row number, it gives us some kind of ordering. Bad. Now the ordering it gives us is a sequential ordering without repeating any values, if that makes sense. So essentially what we could do is get an order from 1 until the end, and then select from 7. Anything that's greater than 7, because the window is 7, would give us what we're looking for. So let's do over as Rn. So it's pretty straightforward. So let's see if we get this, and then we can put a where clause here to say where Rn is greater than or equal to 7. And we've been asked to do a couple of things. So we have to have visited on, and then we have to have something is rounded off. What's that? So amount is the average amount. Told us to round this off to 2 decimal places. Just copy this, put it in here. So this is looking good so far. Let's see if this works. Okay, let's run that. Still says wrong answer. Oh, that's because we haven't renamed this. So usually it's really basic things that mess this up. Awesome, so that's accepted, and let's try to submit this. Perfect, so this gives us the right answer. So let's move to the immediate delivery food question. Immediate food delivery question. So this question is pretty straightforward. Should be able to solve it really quickly. Let's see. So if a customer's preferred delivery date is the same as the order date. So if we see some match between order date and customer preferred delivery date, then we could say that's an immediate delivery. Otherwise it's scheduled, so we want to get all the immediate delivery. So if it's an immediate delivery, then we count it. Otherwise we don't count it. Pretty straightforward. The first order of customer is the earliest date on which they've ordered, and it's guaranteed that customer has precisely one first order. That makes sense. Write a solution to find the percentage of immediate orders in the first orders of all customers. That should be rounded off to decimal places. Okay, let's head right into that. I'm thinking about this problem. So essentially the sample space should be all the customer first orders, and of those first orders, which ones are immediate. So which ones would you say the order that matches up with the customer preferred delivery date? So I like to start by having some table that gets me that filters out for the first orders, and that's pretty straightforward. So you could just copy the customer ID, and then there's a function called minimum. It's a minimum date, order date. That will be the first date. I would like to call this first order, and from delivery table, you would need to do a group by the way, because that's an aggregation function. Group by. Okay, so this essentially should give us what we're looking for. And now, of these dates, you want to find which ones are immediate deliveries, right? So we could join this to some other table. So we could just say join. Forget about the join condition for now. Let's just look at the logic of what's to happen here. So when you have conditional statements like this, and you like to count on a conditional basis, I would like to use a case statement. So select, let's just say case when, apparently I can spell, case when order date is equal to customer date. Then we should give a 1, right? That's like on or off, essentially. Otherwise, else 0. And we have to end this. Now you could wrap this in a sum. So essentially count all the immediate orders is what we're saying here. As, what do we call this? Anyway, it doesn't matter. We haven't finished computing this. So if we were to count these orders, we would like to have that as a as a percentage, right? They've said here. Where's that? Okay, this should be as a percentage of the total number of first orders which are contained in this table. So you could do something like count, and that would be the count of first order. Now remember, if you're joining this table, the outer table, to this one, you would have a distinct number of customer IDs and their first orders here. So if you were to count the entire table, this subtable, that should give you the total number of first orders. That's what we're doing here, right? So from, now this will be from delivery, because we're working with the outer table. From delivery, and I could alias that as D, and join this table. Let's give this an F, right? So this gives us the decimal, and we want to get the percentage. So let's wrap them some brackets and then multiply by 100. So this should work. And now we've been told to round it off as well. Okay. So then we need to round it off. So round to 2 decimal places. Okay. And what do we want to call that? Let's call that immediate percentage. Now, what's going to be the join condition? Think about this. So you have a table where you have all the orders, whether or not they're first orders. That's the outer table here. And if you were to join to this table, in order to have unique values, in order to have only, so first things first, so you have to count where the immediate orders within the first orders. So what you want to do is to join on 2 conditions. The first condition being the order date, and the next one being the first order, the customer ID, I meant to say, pardon me, and the first order. So that would give us the unique sample space we're looking for. So you can just do on and D, the customer ID. So that's the same thing, and then you have another condition which says D. Now this is a bit different, because order ID will be equal to F dot first order, because we're only looking at the first orders essentially. Alright. So another way to do this could be to filter and say, so if there's a sample space of all the first orders, you could do where order date in the larger delivery table is contained within the minimum order. So because each customer has one order, one first order, you could do that as well. That should work. But I think this is neater in that you have the customer ID associated with their first order. You filtered it out by making the join here and having two conditions in the join, and then you can compute the percentage. And hopefully this works. Looks good so far. Let's go. Okay, great. So that's accepted, and let's try to submit this. Okay, says time limit exceeded. What's the problem here? I suspect it's a performance issue, but let's try again. Okay, for some reason Leetcode does that sometimes, but if we look at the score here, say bit 17%, let's see if we can do this differently. Maybe we could do a window function instead. So we could do minimum over, and this will be the equivalent of what I've just done. If you were to do minimum and put that over the partition of customer ID, obviously, because you want to have each customer ID as one partition, and then select the minimum date. And because row functions, or rather, because window functions maintain granularity, you have to put distinct in order to have this distinct. So we've done this, and let's see if this, we don't need the group by now. Let's see if this works better. And there's some problems here. Okay, my bad. So the distinct should come before, for sure. Apparently there's some problems here. Let's see. Distinct. Customer ID is first order. Oh. Partition by. Great. Let's see how the performance plays out now. Okay, this performs slightly better. Because for the most part, I'll say window functions are much more efficient, let's say, compared to group bys. So when the data scales, you might want to try using a window function instead, if you can, if it's not an overkill. Anyway, I'll leave it there. There are loads of other questions on here. You could solve a couple of them if you like, or even the entire thing. I've done the entire thing, and I think it was a really rewarding exercise for me. The hard one isn't that hard, I must say. If you know window functions, you should be able to tackle this. Let's just quickly run through it. I wouldn't solve it. So let's see. It's just top 3 salaries, I think. Top 3 unique salaries. So this is a pretty easy problem. So have a crack at this and let me know in the comments. Thank you.